Learning about the law of sines. So we've talked about how trig ratios relate side lengths and angle measurements in right triangles specifically. The law of sines is going to show a proportional relationship between angles and their opposite sides in any triangle. So we can use these to find lengths and angle measurements for any triangle. And that's an important idea. We can set up a right triangle within a non-right triangle to eventually use these trig ratios. And it's really just broader than the law of sines. There's something called the law of cosines. There's something called the unit circle. So you set up a right triangle within a circle, and then you use these trig ratios to find out important points about that circle. So it's a big idea that you can use right triangles even though you don't have a right triangle to start with. I'm going to show you where this comes from. It's actually pretty simple, the law of sines itself. It says that sine of A, so sine of that angle, over lowercase a, so that's that side length, over the side that's opposite that angle, equals sine of B over the side that's opposite that angle, and that equals sine of C over lowercase c, that's the side that's opposite that angle. So it's the relationship between sine of an angle and the side that's opposite that angle. And I'm going to derive this proportion, or at least part of this proportion, just to show you where it comes from. So I'm going to draw an altitude in that triangle. I'm going to draw a straight line down that's perpendicular to this side AC. And really what I've done is set up two right triangles. I have this right triangle and this right triangle. And I'm going to label that altitude as H. So I want to think about sine of A. Sine of A in this triangle. Remember, sine is opposite over the hypotenuse, so that's H over C. I'm going to do the same kind of thing in this triangle. I'm going to think about sine of C. Again, it's opposite over hypotenuse, so there it's H, that's the opposite side. Over the hypotenuse in that triangle, that's A. All right, now I'm going to solve both of these for H. I'm going to multiply C to the other side. So it would give me C times sine of A equals H. Same idea there. I'm going to multiply by A on both sides. That would give me A times sine of C equals H. And now you can see that these are both solved for H. H equals that. H also equals that. So I can substitute this expression in place of that H. So I'm going to rewrite C. Actually, sorry, I'm going to rewrite it in that order that I said. A times sine of C equals C times sine of A. And now I'm really just going to rearrange these. I'm going to divide by C on both sides. That cancels out, leaves me with just sine of A on the right side, and then A times sine of C over C. And then I'm going to divide both sides by A. This is being multiplied by A right now, so I'm multiplying and dividing by A. Those cancel each other out. If I do it on that side, I have to also do it on this side, so I'm going to divide by A there. And you can see that's where that proportion is coming from. Sine of C over C equals sine of A over A. So that gave us most of that proportion. That other part would just come from another altitude being drawn. We could just rotate that triangle or just draw a different altitude and set up that exact same proportion for a different pair of sides. So that is true in any triangle, which is really helpful because now we don't just need a right triangle to use some trig functions to be helpful. Not that important that you got where it was derived from. That's just a quick proof on that it has to be true in all triangles. But now I'm going to show how to use it. So we want to think about what sides were given and what angles were given. Those two. Those go together. Sine of 35 over 12 is equal to, these two also go together, sine of 71 over x. So sine of 35 over 12 equals sine of 71 over x. I know a lot of you like just using graphing calculator to find your solution that way. I think I figured out exactly why this isn't showing the dot there. It's because we're dividing by x there. That number can't be 0. I think it's something about dividing by a 0 that doesn't want to show a solution there. If you flip these fractions, it keeps the proportion true. 12 over sine of 35 equals x sine of 71, then it does reveal that exact point. I'm actually not going to do it this way. I'm going to solve for x each time. Really, all that would involve is multiplying the sine of 71 over. So I would end up with, actually I'm going to show it on the smartboard. So I'm going to flip these fractions just to make this a little bit easier to solve. Again, if you'd like to use a graphic calculator, you definitely can. I just want to show the right way to do this. I would multiply by sine of 71 on both sides. Those cancel out, and that gives me that x is 12 over sine of 35 times sine of 71. So that tells me that that length has to be 19.78. I'm going to round all these to the hundredths place. And you can always double check to make sure that you set this up right. If you happen to get a number smaller than 12, that really doesn't make any sense. Remember the relationship between angles and their opposite sides. If that's 71 and that's 35, this side has to be bigger than that angle. Sorry, this side has to be bigger than this side because it's across from a bigger angle. So it's got to be bigger than 12. I'm going to do all the odd number problems, and then I'm going to have you do all the even number problems. And I'm actually going to keep this setup exactly the same. I know this is really not going to change. So I'm going to set up these proportions just flipped. Typically, this is how you see the law of sines, but if you flip a fraction on both sides, it remains a true proportion. So I'm just going to flip it and put the side length on top. So I'm going to say x over sine of 59 equals 20 over sine of 73. And I'm really just going to keep this in the calculator to make this as easy as possible. 20 over now sine of 73, that side, and I'm multiplying the sine of 59 to the other side. So I'm going to change that to 59. So that tells me that x is 17.93. On this one, I'm going to need to solve for this angle. I don't have the angle that's across from the x, so I need to figure out what is that angle. I know that they have to add up to 180, so that's 132 so far. So the remaining degrees has to be 48 degrees. So x over sine of 48 equals 15 over sine of 29. Alright, so 15 over sine of 29 gets multiplied by sine of 48. So that's 22.99. Actually, I'm going to skip this next one. I think you could do that one on your own. I'm going to jump to the ones where we have to find the angles here. These are going to be a little bit different. So, same idea. It's still sine of an angle over the opposite side. So sine of x over 9 equals sine of 77 over 14. But solving this one's going to be a little bit different. I want to figure out how to get x by itself here. So I'm going to multiply the 9 over to the other side. That would give me sine of x equals sine of 77 over 14 times 9. And then I want to cancel out this sine function. That's where we're going to use an inverse function, an inverse trig function, or inverse sine to cancel out that function. If I do it on that side, I have to do it to the entire side here. So x would equal sine inverse of all of this in parentheses sine of 77 over 14 times 9. We want to make sure all of that's in parentheses. It's doing sine inverse of the entire side there. Everything on that side. So make sure all of that's in parentheses. So that tells us that that angle has to be 38.78 degrees. Same idea. Sine of x over 21 equals sine of 61 over 24. I'm keeping that in the calculator because I know I'm just rearranging in the same way. So I'm changing that sine of 77 to sine of 61 over 24, and then multiplying the 21 over to the other side. That gives me that x is 49.93. One more. Sine of x over 37 equals sine of 94 over 43. So that angle has to be 59 degrees. 59.13. Again, you can check to make sure that makes sense. Across from the 94 has to be bigger than the side length that's across from that 59 degrees. Alright, I hope this helps you complete those odd number problem or even number problems and number 7.